The projectile thrown off a cliff at some angle. Nice problem. My name's David. I assume if you're watching this video, you know how to solve a problem where the projectile is launched horizontally off a cliff, and the problem where the projectile is launched off the off flat ground up at some angle. And this one is the next, it's like level 3, and more complicated. Again, I assume you know how to solve the individual parts, but putting the whole thing together can be a little bit challenging. So let's go through it. All right, we're going to answer these 3 questions. The main one here is how far does it go in the horizontal direction? That's the range. And we'll address the other 2 as we go along. I'm not showing my picture because there's this big error bar window here that I can't get rid of. You need to draw a diagram, right? Something like this. Here's your cliff. The trajectory of the projectile is like this, up then down, all the way down to the low ground. Here's the initial velocity that we're going to resolve into components, perpendicular components. And I'm labeling this the height above the cliff level, y1, and then the height above the ground level. That's what we're trying to find for this third one here. I'm calling that y2. And I'm going to introduce 2 more variables here, t1 and t2. t1 is the time it takes to reach the maximum height, right, where it's y1 above the launch level, and then t2 is the time for it to fall from that height. That matches up with y2. All right, these are the 8 steps along the way once we get going, 8 calculations. All right, let's just go in order here. And along the way, these are the 3 things, our 3 answers to the 3 questions. All right, first thing you want to do is resolve the initial velocity v0 into perpendicular components, v0 x, v0 y. All right, now we want to find y1, the maximum height above the launch level. For this, we're going to use this formula. This is in the AP. All this notation follows the AP physics reference tables. I'm substituting y for x. I want to keep y and x separate. And I call this the no time equation. All right, we're going to set vy equal to 0. So that's the condition at the maximum height right here. And this is the initial launch velocity squared. And a is going to be negative g, right? It's in the opposite direction than that upward initial velocity. So you substitute, you get y1. It's going to be around 5 or 6 meters. Not very high. For the maximum height, then, we're just going to add that to the height of the cliff, to the 125. So your answer there is going to be less than 135. All right, now to find the times, to find t1, the time to reach the maximum height, we're going to use this formula. This is a positive number, right? It's initially moving upward. I'll call that positive. And so then the acceleration, which is downward, that's going to be negative 9.8, just as in the step C. All right, Vy again is going to be 0. That's the condition here. So you get T1, just going to be around a second or so to reach that maximum height. Now it's going to fall. How much time does it take? The time for it to fall like this is going to be the same as the time if you just dropped it from rest, okay? The fact that it's moving horizontally during that motion doesn't affect the time. So for T2, we're just going to use y equals 1/2, y2 equals 1/2 at squared. And you can just put a positive g in here and solve for that. It's going to be around 5 or 6 seconds for it to fall all the way. Total, you just add the 2 of them. All right, there's your answer for this question, how long is it in the air? And then finally, to get the range, well, we know how long it's been in the air. During that whole time, it's traveling horizontally at this speed here. So we're going to multiply the 2 when we get the range. All right, it's a nice problem. It should get around 30 or so, between 30 and 40 meters for our range. Right? Nice problem if you can complete the whole thing. You have to keep everything organized. Okay.